The AI opportunity. Nobody's picking. Your documents no more than your systems. Billions are being poured into AI strategies. Unfortunately, many organizations are still struggling with finding the right information at the right time. The data exists, but it's buried in PDFs, spreadsheets, vendor manuals, commissioning reports, and design documents that were never meant to connect with each other or with the equipment they describe. Before chasing the next generative AI breakthrough, there is a large opportunity sitting in document repositories right now. The problem hiding in plain sight. Complex industries invest heavily in systems to manage equipment. Asset management platforms, CMMS, digital twin, and configuration databases are common investments. But the problem is that the information feeding those systems is fractured. For example, equipment specifications live in one PDF, but commissioning records are stored in a separate system altogether. Most of these documents were created as standalone artifacts by different teams at different times. The formatting standards vary widely or do not exist at all. The result is predictable. Engineers and operators spend a large portion of their time hunting for information rather than doing engineering work. They have to search across systems, cross-reference tag numbers, and manually verify that what exists in the field matches what appears in documents. Research shows knowledge workers spend 25 to 30% of their time searching for information, with additional time lost verifying data across systems. This leaves only about a third of the day for actual engineering work. Why this is the real AI opportunity. The industry conversation around AI tends to focus on predictive analytics, autonomous operations, and large language models. These capabilities are valuable, but they depend on clean and connected data. Here's a simple example. A predictive maintenance model can't function if equipment can't be reliably linked to its maintenance history, design specifications, or operating parameters. An AI assistant for operators can't deliver reliable answers if the documents it depends on are duplicated, inconsistently named, or disconnected from the assets they describe. Most advanced AI use cases rely on a strong data foundation. Many organizations do not yet have that foundation. The immediate opportunity is using AI to solve the data problem first. The technologies required to do this are already mature. For example, OCR and layout-aware models can extract structured information from scanned PDFs, P&IDs, and engineering drawings. Named entity recognition can identify equipment tags, instrument numbers, and component identifiers within technical documents. Semantic search can interpret document meaning rather than relying on file names or keywords. Relationship mapping can link documents and assets by identifying shared equipment references. None of this requires replacing existing systems or launching multi-year programs. These tools can be applied to existing document repositories and begin delivering value within weeks. Document parsing and OCR engines now exceed 98% accuracy on printed text 3. Named entity recognition models reach F1, scores near 95% for domain-specific entity extraction 4. These capabilities are already production-ready, while many predictive and autonomous applications remain in early stages. What this looks like in practice. Consider a scenario that appears frequently in facilities. A midstream operator manages a facility with 15 years of accumulated engineering documents. Thousands of files exist across shared drives, document management systems, and vendor portals. P&IDs appear in one format, but datasheets appear in another. Vendor manuals are usually scanned PDFs, and maintenance reports live in the CMMS. Commissioning records may or may not have been properly filed during handover. An engineer troubleshooting a control valve must search multiple systems, open dozens of documents, and cross-reference tag numbers against outdated lists. Maintenance history in the CMMS may or may not reflect work performed in the field. Hours or even days can pass before enough context is gathered to make a confident decision. Now imagine a different approach. An AI layer sits on top of existing repositories. Every document has been parsed, Equipment references have been identified, and key attributes such as manufacturer, model, specifications, operating limits, and service history have been extracted. Relationships between documents and assets are mapped automatically. The engineer enters the valve tag number and immediately sees the complete context. The original design datasheet appears alongside the vendor O&M manual, the relevant P&ID section, maintenance work orders, commissioning test results, and applicable design standards. All information is linked and presented in context without reorganizing a single file. The system can also surface issues that humans easily miss. For example, a datasheet may specify a pressure rating that conflicts with a maintenance procedure, or a vendor bulletin may exist that was never linked to the asset. These discrepancies cause downtime, safety risks, and compliance issues. They remain invisible when information lives in disconnected documents. Nearly half of enterprise information is not centrally indexed or searchable. 5. AI-driven linking can transform scattered documents into a connected knowledge graph organized around the assets they describe. The standards gap is the real bottleneck. The persistence of this problem does not reflect a lack of technology. The real issue is the absence of document standards that allow systems to interpret relationships. Most engineering and operational documents are written for human readers rather than digital systems. Naming conventions vary, references are unstructured, and file formats make automated interpretation difficult. AI can extract structure from existing documents, but the long-term solution requires better standards. Tag naming conventions, structured metadata, and consistent reference formats allow information to remain connected across systems. These investments rarely attract attention, but they form the foundation of every successful digital initiative. Around 70% of organizations are piloting document workflow automation, yet unstructured data still accounts for roughly 90% of enterprise content, 6-7. This imbalance explains why foundational data work must precede advanced AI initiatives. How ReVisionz helps. Solving this challenge requires both industry knowledge and digital expertise. Technology vendors may deliver tools without understanding operational realities, and traditional consultants might deliver strategy without implementation. ReVisionz combines both perspectives. Teams understand tag hierarchies, engineering document workflows, regulatory requirements, and the day-to-day realities of operating industrial facilities. Experience across hundreds of engagements has produced proven frameworks and tools that accelerate progress. What this work typically involves: assess your current state. Document repositories and asset information maturity are evaluated to determine where data resides, how it is structured, and where gaps exist. Extract and connect. ReVisionz applies our tag extraction AI tool to detect and reconcile asset and material references across systems, even when naming conventions differ. Delivered as part of our AI readiness services, these capabilities transform disconnected engineering documents into structured, reliable asset data. Organizations typically see cost reductions of up to 60% compared with manual review. Gartner reports that intelligent document processing can reduce manual data entry costs by up to 60%. 8. Roughly 70% of data entry tasks can now be automated through IDP solutions. 6. In asset-intensive industries, these improvements translate into faster project execution and lower operational costs. Establish standards and governance. Naming conventions, metadata frameworks, and data quality rules are implemented so that information remains connected going forward. Implement and sustain. Solutions such as digital twins, asset information management platforms, and engineering data warehouses are implemented with training and long-term sustainment support. The approach is practical and incremental. Organizations can begin with existing documents and build toward a connected digital foundation. The takeaway: if teams spend more time searching for information than acting on it, the most valuable AI investment is not a chatbot or predictive model. It is unlocking the knowledge already stored in documents and linking it to the equipment those documents describe. This opportunity may not attract headlines, but it delivers real operational impact. It is achievable today and addresses a problem engineers encounter every day. ReVisionz works with asset-intensive organizations to unlock the value contained in engineering documents and asset information. To learn more about how these challenges can be addressed, connect with the ReVisionz team.